Let's take a look at the second free response on the vector and projectile test. This is number 15. And again, I'm going to scroll up here in case you just want to find the parts you need help with. And then I'll go back, and you should read this over carefully. And then follow along with me if you think you need to. And so we're firing a cannon at an angle, so these can be tough. And we know how fast it's going and the angle. And the first question is just what are the initial vertical and horizontal components of the velocity? And so there's a vertical component that's opposite angle theta, and a horizontal component that's adjacent to theta. And so the horizontal component I'm going to call V0x. It's just the magnitude, 180 times cosine 38, and we get 141.84. And V0y, it's opposite, so it's sine 38 times 180, 110.82. So 1 point each. What is the maximum height of the cannonball? And so the key thing is at maximum height, the y velocity is 0. And so Vy is 0 at this point. So the way I did it is I took the equation for Vy, solved it for time, and put in 0 for Vy. I put in my V0y from above here, and divided by the acceleration, which is negative 9.8. I'm making up positive, and I get 11.31 seconds. And then I can put that into my y position equation and find out what is my y position at 11.31, and I get 626.8. So that's kind of the long way of doing it. You can use the good old v squared minus v0 squared is 2a times change in y. Just make sure you put in that would be v0y here. So try that. Or you can get the average y velocity and multiply that by this time. And so the average y velocity would be 0 plus 110.82 divided by 2. All those good ways of doing it. And then the cannonball is going to land on the hill. And part C is how much time until that happens. And so it's the y motion that determines that. Without gravity, it'd never land on the hill. So gravity acts in the y direction. So we need to look at the y motion. And I carefully substitute everything I know about the motion here. So I know that the final y position is 30. That's the height of the hill. The initial is 0. So I'm making the ground here my origin. Probably should have indicated that, but it's kind of obvious. And then the initial y velocity I already have from part A. And again, the acceleration negative 9.8. The acceleration is down. I made up positive, so it's a negative acceleration. And you get a quadratic, and you solve for it. And you may have been puzzled because you get two positive answers. What's this one? Well, doesn't it have to cross 30 on the way up too? And so I want the later time when it crosses 30 on the way down. That's the only way it can hit the cliff. And D, how far in the horizontal direction does the cannonball land from where it started? So if we have the right time, that one's easy. And so we look at the x motion. And again, it's the same equation as this one, except I don't bother to write the 1/2 a t squared because ax is 0. And so I just write the same equation that I did up here for the x, and I know the initial x velocity, and I use the time from up here, and I get how far it went. And so no matter what time you got, as long as you use the right, as long as you use your answers from above, v0x, and the time, you got this point. And so now kind of a tricky one you hadn't really seen before. What if we drive the cannon toward the hill and fire it? And so what that does is the cannonball already has some velocity from driving it. And so there's two ways you can handle that. You could take how far it went without this additional velocity and add the velocity times the time it's in the air. Or you could think, hey, my x velocity now is not 141.84, it's 141 plus 15 from the fact that it's being driven. And both of those gives you the correct answer. And so that was worth 2 points, one for somehow coming up with a way to handle the 15, and one for the correct answer.